Hello there, that's Alana, and I received a question about this problem, which is 3.4.5 in the study plan or the textbook if you open up the textbook either online or a physical book if you had one. And it's in the homework wherever it might show up for your homework set. All right, so let me view an example here, make it bigger. All right, suppose babies born after a gestation period of 32 to 35 weeks have a mean weight of 2,400 grams. Well, technically, weight is not measured in grams, but whatever. It's mass, and a standard deviation of 700 grams, while babies born after a gestation period of 40 weeks have a mean weight of 2,600 grams and a standard deviation of 410 grams. If a 33-week gestation period baby weighs 1,850 grams and a 40-week gestation period baby weighs 2,050 grams, find the corresponding z-scores, which baby weighs relatively less relative to the gestation period. Okay, so there's a whole lot to unpack here. So you're comparing two different things. You're comparing babies that were born with a gestation period of 32 to 35 weeks with one that was born with 1/40 weeks. So it's sort of like you're comparing apples to oranges. No, there's no question the 40-week-old baby is heavier. They're 2,050 grams. That's heavier. So if they ask you, which one is absolutely heavier, well, it's the 40-week baby. But see, the thing is, they're asking which one's relatively weighs more. That's a different question, because 40-week babies, because they've been inside the mother longer, are going to be heavier. So you want to find a z-score then and figure that out. So let's remember a couple things. First of all, there's the z-score formula, which is, you can say it x minus mu over sigma, which is what it would be in this particular problem. Or if it was for a sample, it would be x minus x bar over s. There's the formula right there from the notes. Okay. All right, so let's think of this out. So we need to do the 33-week baby first. All right, well, let's see here. 33-week baby weighed how much? 33-week baby weighed 1,850, right? 1,850. Now the mean mu for 33-week babies is 2,400 and a standard deviation of 700. So you put 2,400 over here. Whoops, come here. 2,400 over standard deviation of 700. Oh, holy moly, don't do that. All right, there we go. So there we have it. So now we just need to find this. Now, you want to be a little bit careful with your calculator or with Excel or whatever you're using this with. So you want... What you don't want to do is type 1,850 minus, don't do this, but you can watch me do it and realize how much I'm messing up in here. Hold on, I'm going to make this smaller so you guys can see. So 1,850 minus 2,400 divided by 700. Because what it's going to do then is it's going to take 2,400 and divide it by 700, whatever that is, and then subtract from 1,850. But the order of operations that you learn in pre-algebra class says that you have to do grouping symbols like parentheses before you can do division. So you have to find what this numerator is first and then divide it by 700. Now there's a lot of ways you can do that on a TI calculator. And it's the same with Excel. So you could use parentheses. 1,850 take away, sorry, I can't remember the numbers, 2,400, 2,400, close the parentheses, then divide it by 700. That would work. Or you could use the new, if you have the new operating system, you can go alpha, I think it's F1, there it is, alpha F1 N over D. And you could say 1,850 minus 2,400, down arrow 700, enter. Or you could do math fraction, right? Oh, not that, here. Math. If you go to the nope, it's over in the number thing. There it is. If you have the new operating system at the bottom of the number, NUM, in the math menu, it's N over D. That's giving you a fraction. Of course, you don't really want a fraction, so you press math, number 2, decimal, and convert that into a decimal for yourself. All right. All right, or let's say you have Excel, you would use the same idea. So you type equals, parentheses, 1,850 minus 2,400, close parentheses, divided by 700. That's how to do it all at once. Or if you want, you could take 1,850 minus 2,400, find that number, and then equals that cell divided by 700. That would work, right? Lots of ways to do it. Okay, so either way we get negative 0.7857. It's negative 0.786. I don't know how many decimal places they want. And it's a squiggly equals because we're rounding here. All right, let me go back here and see what they wanted. How many decimal? Oh, they only want 2 decimal places. Now, real quick, when I looked at the problem, I noticed that it wants it answered in this particular way. It says the baby weighs blank standard deviations, and I bet you this is above or below. Yeah. Okay, so what you're going to say for this particular one, for example, would be the baby weighs 0.79 standard deviations below the mean, right? Below because it's negative, right? The average was 2,400 and this kid is only weighing 1,850. All right, then you just repeat the whole process for the next week baby, right? So you have the 40-week baby. So let me copy and paste that kind of down here for ourselves. Let me bold this because those would be the answers you'd actually fill in on this thing. All right, and then you got your 40-week baby right here. Now, how big was that kid? I think it was 20 something. That baby weighed, oops, sorry, I need to view an example. Okay, that baby weighed 2050. Okay, so 2050, 2050. But their standard deviation is something much smaller. I think it's like 410. And the average mean was 2,600. 2,600. All right, so now what is that? Parentheses, it's probably just easier just to do parentheses. Parentheses, 2050 minus 2,400. Oh, was it 2,400? 2,600. I thought I'd messed that up. Minus 2,600. Close parentheses, divided by 410, enter. So it's negative 1.34. Okay, so that means that the baby weighs 1.34 standard deviations, again below the mean. One other thing to think about. So the 40-week baby, and I know it didn't ask this question here, but something to think about for an exam, say. The 40-week baby is absolutely larger because it weighs more, right? It weighs 2050 grams versus 1,850 grams for the smaller baby, okay? So in absolute terms, it's a bigger baby. But the 33-week baby is relatively larger. They're both small, by the way. I don't know if you noticed that, right? That's another thing to mention. So I'm going to make some notes here. If I could type, good grief. Okay, so both babies are small for their age. Both babies are small for their gestations because both are negative. Now, the 40-week baby is actually the bigger baby in absolute terms. I mean, if you had to pick up this kid, the 40-week baby would be, more of a workout. But the 33-week baby is actually relatively larger because its z-score is higher up. It's higher. Now, I know what you're thinking. You're thinking, well, 1.34 is a bigger number. But that doesn't matter. I mean, when you're thinking about z-scores, you want to think about a number line. Here, let me grab a picture of a number line. There we go. Okay, so the mean is in the middle. So if a baby was exactly the mean, then their z-score would be 0. And remember, anything below -2, over here on the left, -2, -3, actually -4, and so on, would be unusually low. Anything 2, 3, 2.5, 2.65, 3.45, 4.2, anything past 2 is unusually high. Neither one of these babies is unusual, right? That's another thing to note. Neither baby is unusual because their z-scores are not below -2, nor are they above +2, right? Being past -2 over here or past +2 over here is unusual. Anywhere in between -2 to 2 is fine. So one kid's over here at -1.34. That's between the -1 and the 2. And the other baby's over here between the 0 and the -1. Matter of fact, let me put some points in there. There we go. So there the two of them are, right? So this baby, the red baby, which is the -1.34, is further away from the mean. Well, on a number line, being over on the left means you're smaller, and being over on the right means you're bigger, right? So the child that's actually larger is actually the 33-week-old baby because its z-score is higher. It's farther to the right on the number line. If they were both positive numbers, if it was positive 1.34, which would be over here, right, and positive 0.787 over here, then the red baby, the 40-week-old baby, would be the bigger baby, right? But that's not how it worked out. It worked out that the 40-week-old baby was over on the left here, and then the 33-week baby was over here. That means that the 33-week baby, if I can move it, come here. The 33-week baby is actually the bigger baby in relative terms, not in absolute terms, because 40-week-old kid's still bigger, but in relative terms, in relation to all the babies that are having the same gestation period, the 33-week-old baby is the bigger baby. Well, that was a lot more than they actually asked, but it was a good question to look over for, say, I don't know, exam questions and similar to that. All right, I hope that helps.